Today we want to learn about a gamma distribution. So number one, we have to define what we call the definition of gamma distribution. From there we look on how we find the mean and variance, as well as the standard deviation. And then from there, we're going to look at one or two examples, and therefore we'll be able to understand what it all entails about gamma distribution. So at the start, let us look at the definition. We say that y is distributed as a gamma variable with parameters alpha and beta if it has a corresponding PDF, which is the property of y given alpha and beta is being equal to beta power alpha out of gamma into alpha, then y, then raised to power alpha minus 1 exponential negative beta, then y. So from the definition, that is all about what entails about the definition of gamma distribution. From there, we can also be able to know that if we have a standard deviation, if we have a standard gamma distribution, then beta is equal to 1. This is when we have a standard gamma distribution. Then if alpha is equal to 1, then we have what we call, when our alpha is equal to 1, then we have exponential density function. Exponential density function. So in a question you might not be given, maybe you can just be told that this is a standard gamma distribution, and therefore you are supposed to know the value of beta must be equal to 1. Or when it is an exponential density function, a question can just mention like that, and then it can tell you that alpha is 1. So therefore you are supposed to have that one in mind. Please take note of this. From there, let us look on how we can find the mean of a gamma distribution. So if x has a gamma distribution with parameters alpha and beta, then the mean, that is the expectation of x, can be obtained by, that is also known as mu, can be able to be obtained by alpha out of beta. Also, we can note that the gamma into the alpha is known as the function of alpha. This is the same as this one, and therefore to get the mean, it is alpha out of beta. So how can we now obtain the variance and standard deviation of a gamma distribution? Variance and standard deviation. So for us to be able to obtain the variance, that is of x, is equal to sigma squared, which is equal to alpha out of beta squared. So you just take the formula of the mean, and then it is now beta squared. And then, of course, we know that the standard deviation is equal to the square root of variance. And therefore, to obtain the standard deviation from the variance, what you just do is just the square root of sigma squared. That is, of course, sigma. It will give us sigma. Now that is standard deviation will be given by the square root of alpha out of beta squared, which is like the square root of alpha out of beta. And that is how we obtain the standard deviation given a gamma distribution. Now before that, we can be able to also know that about the something we call a chi-square. It is so important to know this, a chi-square. In case you are given a chi-square, you can be able to find that, of course, from our explanation, say suppose x is a chi-square, a random variable with degrees of freedom, that is 3 degrees of freedom, then the mean the mean is you can be able to obtain the mean by is the same as the degrees of freedom, the phi degrees of freedom. That one gives you the mean, and of course the variance, that is sigma squared, is given by 2 phi, and of course its standard deviation will be the square root of 2 phi. And that is all as our simple explanation, the summary of gamma distribution. So now let us, without much ado, take our example number 1, which says that suppose the reaction time of a randomly selected individual is on a certain stimulus as a standard gamma distribution with alpha 2 seconds. Find the probability that the reaction time will be Roman 1 between 3 and 5 seconds and Roman 2 greater than 4 seconds. We can be able to say that from here, of course, there's also a point, an important point to note, but I will explain that one shortly. We say that our formula says that beta by alpha out of the function of alpha, then we have y alpha minus 1, that is to the power, and then exponential negative beta times y. So but now when we have our question, for example in this case, is continuous, so it's between 3 and 5 seconds, and therefore we're going to change the formula in a straight manner to be able to fit our question. So we simply say that it is the integral, that is, we can say fx. We'll go to integral maybe from a to p, then of course beta power alpha out of the function of alpha, and then x, we now use x, then it will be alpha minus 1, and then exponential negative beta times x, and then of course dx. That is what we do when our question, for example, is continuous. You can say at Roman A, it is between 3 and 5 seconds. So what I'm going to do here, it is the integral from 3 to 5, because it's 3 to 5 seconds. Then of course, being a standard gamma distribution, we know that beta is 1. Beta will be 1, and of course, alpha, our alpha is 2, so we squared is the power of 2, because they were saying our alpha is 2, it's given here 2 seconds. So, and then out of the function of gamma, which is like gamma into alpha, the function is written like that, or it is written like this. So we take one in each case, we don't take both of them. And then of course x power alpha minus 1, and then of course exponential, it is now negative x because beta is 1. Now we have that one. So what we are going to find, it was the probability between, that is the probability between when x is less than or equal to 3, and then this x here, let me write it in a good way. So probably that 3 is less than or equal to x is less than or equal to 5. So it's been given by this now. So having reached that point, and therefore what we have to do, the next step, we can see that it will be the integral from 3 to 5, of course, x power 1, and of course e exponential negative x, then of course dx. Because our beta is 2 seconds, our beta is 2, so when beta is 2, we can know that this one, it is like 2 minus 1 factorials, and therefore we're able to obtain 1 factorial, and that one will give you 1, and that is why we have just excluded here in our question. So up to this point, we now apply integration by part, where we say the integral from u d phi is given by u phi minus phi the integral of phi du. We just apply it here to solve this part. So in applying that, we can say that let u is equal to x, and of course we let d phi to be equal to the remaining part, it is exponential negative x to the power of negative x, that is. So we can be able to find that if u is equals to x, then it means du is equals to dx, and then here to get phi, it means it is the integral of exponential to the power of negative x. So if we want to obtain phi, and therefore phi will be given by negative exponential negative x. So we have integrated that, and what we have to do here, we just combine what we have. So we will to find that negative x exponential negative x minus the integral of negative exponential then to the power of negative x, and of course dx. So we obtain that negative x exponential negative x minus exponential negative x, and of course plus c. We can realize that this one and this one is similar, and therefore we can be able to factor out negative exponential negative to the power of negative x. Then we remain with x plus 1, and of course plus c, and the limits were from 3 to 5, and therefore inside this one here the c will disappear because we have to limits, and then we obtain our answer as 0.1587. So let us go to the second part of the question that was asking us to find the part of the question was saying greater than we are finding the probability that the reaction time will be greater than 4 seconds. That is our Roman 2. We say that the probability that x will be greater than 4 seconds. Remember, it is the probability greater than 4 seconds. It is greater than 4 seconds. This one, if we do it in such a way, we can't know the end because greater than 4 seconds. It is from 4, that is greater than 4 up to infinity, and therefore we can't be able to find that in such a probability. So we simply say it is 1 minus the probability x is less than or equal to 4. So and then we say that it is simply 1 minus from that is the integral we have now from 0 to 4, and we have x. We just take this part because we realize the other part will simply give us we just take this part here. We take this part here because the other part, even though we solve it, it will just give us 1, and therefore let us just take this part. Taking it here, it is giving us x exponential negative x dx. Let us integrate that using the same method that we used, so there's no need of repeating, just follow the process and we'll be able to obtain this one. So it is 1 minus negative x plus 1 exponential negative x. The limit is from 0 to 4. We can be able, in substituting this one, we can be able to obtain 1 minus 5 exponential negative 4. So it is giving us 0.09158. So let us take the other example 2, the last one, for you to be able to fully understand what we mean when you talk about gamma distribution. So example 2, suppose the specify for time x in weeks of a randomly selected male mouse exposed to 240 rads of gamma distribution with alpha is equals to 8 and beta is 1 out of 15. The first part of the question, find the expected value and the standard deviation of the survival for time, and part B, what is the probability that the mouse survives part A between 60 and 120 weeks, and then part 2 at least 30 weeks. So let us find the solution to the same question. So what we do here, when we talk about the expected value, that is simply, we know that it is the mean. It is the mean, which we find by alpha, that is alpha out of beta, which is simply 8 out of 1 out of 15, which is like 8 times 15, which is giving us 120 weeks. Let us go to the other part. We're talking about standard deviation also. So standard deviation, we'll be able to obtain that by 8 times 15 squared, which will give us 42.4264 weeks. So then part B of the question, the part B, what is the probability that a mouse survives between 60 and 120 weeks? So we are finding that probability. So it is probability that x is less than or equal to 60 and of course up to 120. So it is simply the integral from 60 to 120. That is applying our formula, 1 out of 15 power 8. Of course, the function of 8 now. Function of 8. X power 7, exponential negative x out of 15 dx. And then the next step now, having reached this point, we know that we have x out of 15 here. We can simply let x out of 15 be y. Now that this one is y, we can also say that now x will be equal to 15y. Therefore, let us now substitute. Let us substitute. This is 15 to the power of 8. It is now, because this is x, we can even, that one changes even our limits, because now substitute with 60 out of 15 and then to get now the limit in terms of y from our definition. I hope you do remember, keep on the track. So it is now the integral x, that is 60 out of 15, it is giving us 4, and then 120 out of 15, it is 8. So it is 1 out of 15 power of 8. Number 15 power of 8, right? 15 power 7 times, of course, 15 to the power of 1, and then the function of 8, which is like 8 minus 1 factorial, and of course it is 7 factorial, and then x power 7. But now we said instead of x, it's actually 15, because it is 15y, so it is 15y, this one power 7, and then exponential. Actually this was negative x, that was negative x, and therefore it is negative y dy. But even dy, we can be able to substitute even dy, because dy is actually 15, that is, instead of dx, it is 15 dy from here. So we can be able to say that this one and this one cancels out. What remains is the integral from 4 to 8. So we have, this is 15 power 7 and this is 15 power 7 y power 7. So because we said let x out of 15 be y, so you can get x to the power of 1 and then 15 to the power of 1. So even when it's the power of 7 and then the other y's to the power of 7, that one will simply give us y. So it will give us y. So that is why now when substituting it, we can be able to say that we can be able to obtain 15 power 7 y power 7 out of 15 power 7 times 7 factorials exponential negative y dy. So y and the 15, so what will we obtain here? In substituting that, we can factor 7 factorials out because it's a constant. 1 out of 7 factorials out, therefore we can be able to remain with the integral from 4 to 8 and then y power 7 exponential negative y dy. So up to this point, again, we apply integration by part formula. Integration by part formula, the integral of u d phi is equals to u phi minus the integral of phi du. So we say let t is 1, that is why you can say let u is equals to y power 7, but there's a trick here. So when we have said let y, and then of course our dv will be equal to exponential to the power of negative y. So what we simply do here, we just, because when you find for du out of dy, in the first case we obtain 7y, so we continue the process until we obtain a whole number. The process continues until we obtain a whole number, and going through the process you can be able to find that there is a negative outside here, and then we have y power 7 plus 7 y power 6 plus 42 y power 5 plus 210 y power 4 plus 840 y cubed, and then plus 2520 y squared plus 5040 y plus 5040. Now we've obtained our number, then we stop there, and then we add exponential to the power of negative y out of 7 factorials. The limit was from 4 to 8, and in putting that one, you can be able to see that it gives us 26 110 for exponential negative 4 minus 680 5296 exponential negative 8 out of 7 factorials. Working out this one, you obtain 0.4959. So part 2 of the question, at least 30 weeks. So the probability of x greater than or equal to 30 weeks. So it is actually the integral from 30 up to infinity, and then 1 out of 15 to the power of 8, and then the function of gamma 8, so x power 7, x power negative x out of 15 dx. And reaching here, follow the process once again that I've just explained above. So you use integration by part formula, and going through the process, you can be able to see that you will obtain 0.9989 as your answer. Please, thank you so much for watching. I hope you have found it simple and you have enjoyed about gamma distribution.